Vectors. In medical parlances also there is something called vector-borne diseases. So there are some diseases that can be carried by mosquitoes or flies or fleas or some other smaller insects also. So in the medical parlance, sometimes these insects are called vectors of diseases. However, the vectors that we are going to deal with right now are not biological, rather they have more to do with mathematics and physics. So what are vectors? There will be some quantities that you measure which are defined properly on the basis of their magnitude and the direction. Such magnitude, such quantities are called vectors. Imagine a situation that a car is traveling due east at the speed of 50, then it takes the corner, turns towards south, continues to travel at the speed of 50, and for some reason takes the west direction, continues to travel at 50, and goes further south at the speed of 50 only. These are not distances, these are the speed of the car. As you can see, more or less the speed has been 50, and that's a good information. But we would like to know something, that speed is just a scalar quantity. Scalar quantities can be measured, and that's the end of it. They have got nothing to do with direction. Now let's look at the same story from a different perspective. This time, the first 50, it's 50 kilometer per hour due east. Next one is 50 kilometer per hour due south. Then we have a 50 kilometer per hour due west, and finally we have another 50 kilometer per hour due south. This first situation is different from this second situation and still different from this third situation. Okay, 50 kilometer per hour due east is the velocity of the car. 50 kilometer per hour due south is another velocity of the car. So velocity is a quantity which will have some measurement, some magnitude, and also the component of direction. Without direction, velocity can't be defined properly. So velocity is an example of a vector. There could be some other examples of vector also. The force that you apply on any object is a vector quantity. So if there's a football and if you kick it in this direction, it will go further towards west. If you come from the other side, if you hit it towards the south direction, it will go south. So from which direction you are hitting it and which direction you are aiming it for, that is a component hidden here when you apply a force. So force is a vector quantity. Similarly, in physics, you study about momentum, which encapsulates the component of the mass of the object and the velocity of the object. Momentum is also a vector quantity. Displacement is also a vector quantity. Let's go back to the car question once again. I'll erase a few things. Yeah. Let's say the journey had started from here, the spot A, and the journey ended at the spot B. Okay. Let's say the car has traveled 20 kilometers towards east, then 20 kilometers towards south, then let's say 10 kilometers towards west, and just 5 kilometers towards south. I've tried to maintain some kind of a scale. So what's the total distance traveled? The distance traveled is the sum of all these smaller parts, 20 plus 20 plus 10 plus 5. which takes you to 55. The distance traveled is 55 kilometers. However, if somebody asked you what's the displacement, what's the actual, how far is B displaced from A? For that, you need to figure out the straight line distance between A and B, which is this one. Yeah. If you go by the similar scale, maybe this will come out to be somewhere close to 30. So if we could imagine a straight line distance between A and B, this straight line length will be called the displacement of between A and B. You can say that B is displaced 30 kilometers towards southeast, isn't it? So the distance between A and B is 55 kilometers, but the displacement, how far is B displaced from A? You would say 30 kilometers southeast. And you can see that displacement is actually a vector quantity. How do we denote a vector? Let's say I have a situation like this. There's a spot A and another spot B. The vector from A to B is like this. The arrow goes from A to B. Arrow takes care of the direction, and the length between A and B takes care of the magnitude. You could call it AB with this arrow sign. This is the vector AB. Sometimes we also denote this vector by a small letter. I can write it like a small letter with this curve, or I can write it with a small letter with arrow. And sometimes in books they use very bold letters to write the same vector. So bold letter with bold small letter, smaller case letter will also represent a vector only. These are the methods adopted by us while writing about vectors. So these are the three methods. All right, by the smaller representation or by the representation used by the corner points A and B. Imagine we have an origin. Origin in every context can be different. We have a point P here, we have a point Q here. So there could be something called the position vector of P with respect to the origin. For that, you join OP. Okay, you put an arrow towards P from O to P. So this OP vector, is actually the position vector of P. You can write with respect to origin, or you could ignore it. Similarly, OQ with this arrow towards Q. OQ is the position vector of Q. Let's not write with respect to origin. Okay, but let's join PQ and see what happens. It's a new vector. In case I make an arrow from P to Q, this will be the vector PQ, and it will be actually position vector of Q with respect to P. So here mentioning with respect to which point becomes essential. All right, and this is nothing but the vector from P to Q, where P becomes the original point and Q becomes the destination point or the final point. All right, this is PQ. Now look at something very carefully. Whether I go from O to P and then from P to Q, I will reach Q only. Alright. And on the other hand, if I go from O to Q directly, I will again do the same thing. I'll reach Q only. But here the case of distance and displacement comes and plays a role. So in the vector language, we say that the sum of OP and PQ results OQ. So let me write that for you. I'll write it here only. The sum of OP and PQ results in OQ. Alright. Now applying some simple laws of mathematics, send the OP to the other side. You will have PQ equal to OQ minus OP. Alright. Look back into the picture. So PQ vector could be written in terms of the position vectors of the corner points, and it will be the position vector of the end point minus the position vector of the initial point. That's PQ. Okay. So if I create a random vector AB, the meaning is OB minus OA. Yeah. If I create another random vector, let's say LS, this means the position vector of S minus the position vector of L. This becomes quite useful as we go forward. We'll soon study about the geometric forms of vector. So if you have been given something called a 50 kilometer per hour, let's say northeast, you could write it like, you could make a small line segment and with a direction towards northeast, write a 50. This is 50. This could be shifted here, this could be shifted here, but as long as it remains 50 and as long as it does not change its direction, all these three vectors are same. If this is vector P, this is vector Q, this one is vector R. If we say that there were three cars moving in the same direction with the same speed, we can confidently say that in vector language, the vector P is equal to vector Q is equal to vector R. This was just geometric representation.